Hello children, in a previous class we discussed the basic concept of vector. So there we discussed what is a scalar, what is a vector and how can we represent the vector. Children, it's a very important. So understanding the representation of vector is very important. The reason is that throughout chapter we will be using that notation only. I mean that graphically how can we represent the vector. Children, as we discussed that vector is nothing but what children? Directed line segment. That's what. In order to represent any vector, so we use straight line given arrowhead. Straight line given arrowhead. So which means what is children here? Means it is representing some magnitude. I mean the length of the line gives the magnitude of the vector, whereas this arrowhead gives the direction of vector. And it's very important to understand and remember that the magnitude of the vector is directly proportional to the length of this line. Okay children, this is what actually we discussed. So link is given in the description. Kindly go through that link so that you can understand what is a vector. I mean you can get the feel of the vector. In today's class children, we will be discussing the types of vector. Children, these types of vectors are very important. So don't by heart the types of vector. So each and every type of vector we can understand with the help of example. I mean first we take example so that you can understand what type of vector is it. So for that again I am telling you, don't by heart the vector concept. It's a very easy. Let us proceed with some examples so that you can understand all the types of vectors. So children, as I told you that any vector can be represented with a directed line segment. Either it is a velocity vector or a force vector or anything. Okay, fine. So now we'll try to understand these types of vectors, not all, few, by taking a velocity vector. Okay, fine. So first children, so let us take a first example. What is the first example? For suppose children here, two persons, let us say here person A and a person B. Try to understand person A, person B. These both are running with 10 meter per second in east direction. Both are running with a 10 meter per second in east direction. So then how can we represent? Look at here. So here I can represent, let me take here for example, both magnitude is same, I should take the same length. So same length let us take here is. So one more vector also I have to. Why I am taking parallel? Because both are running, both are going in the same direction. So here let us say a velocity of person A I can represent with this. So velocity of a person B is like this. Now if you can see the children, so here these two velocities, these two vectors having same magnitude in the same direction. So if any two vectors, if they have same magnitude and the same direction, then those vectors are called equal vectors. Very simple, equal vectors. So what are equal vectors children? The vectors which have same magnitude and same direction. Children, I repeat once again, the vectors which have same magnitude and the same direction are called equal vectors. Is it clear? Fine. Now let us take one more example. This time person A is running with 10 meter per second towards east, whereas one more person B is running with a 10 meter per second only, but towards west. Try to understand. So then how can I represent? So the velocity of a person A is this, towards east he is going, and as magnitude is same children, so we need to take the length same, means same length should be taken for this straight line. So here it is this. So it is velocity of person B. Means if you can see the children, in this case actually, so magnitude is same but direction is opposite. Such a vectors are called negative vectors. So what are negative vectors children? The vectors which have same magnitude but opposite in direction, means direction is opposite and the magnitude is same. Such a vectors are called negative vectors. Such a vectors are called negative vectors. Let me write here. Such a vectors are called negative vectors. So here I can write. So for equal vectors we can write so velocity of a person A is equal to velocity of a person B. Okay, but whereas here velocity of a person A is equal to minus velocity of a person B. So here minus represent what children? It represent direction is opposite. Okay children, fine. So it's a equal vectors and it is a negative vectors. Now let us take two more examples so that we will make it more simple. I mean further, this is a second type of vector. For suppose here, now let us do the same thing. Now in this case, the person A, okay, is running in this direction with 10 meter per second, 10 meter per second, whereas person B is also running or walking or anything, whatever it may be, okay, with a 5 meter per second. Means both are going towards east only. Means if you can see both magnitude, the magnitude of the velocity is different. Okay, then how can we represent? Look at here. So in this third case children, so velocity of a person A, so I need to represent with like this, but velocity of a person B, to represent a velocity of a person B, I should take the length a bit smaller, almost half I should take. Why? Magnitudes are different but direction is same. Okay, fine. So here I should take like this. So this is a velocity of a person B. So these vectors are called parallel vectors. These vectors are called parallel or like vectors. Parallel or like vectors. So what are parallel vectors or like vectors children? The vectors which have a different magnitude but same direction are called parallel vectors. So it's very important. It's very important. So equal vectors are parallel vectors. Means all equal vectors are parallel or all equal vectors are like vectors. But all parallel or like vectors cannot be equal. Why? The direction is same but magnitude is different. Let me repeat once again. All equal vectors are parallel vectors only, but parallel vectors cannot be equal vectors. Is it clear? Fine. Now children, so in the same example, in this example only, let us change this one. So person B like this, which means what? Person A is going with a 10 meter per second in east, person B is going with 5 meter per second towards west, quite opposite. Now how can we represent their velocities? How can we represent the velocities of these two persons? Look at here. So fourth example let us take. So velocity of person A in this direction because towards east only, whereas person B is towards like this. This is a velocity of person B. So such type of vectors are called anti-parallel. Very important. Anti-parallel vectors or unlike vectors very important to understand. So what are unlike vectors children? So the vectors which have different magnitude and opposite in direction are called anti-parallel vectors or unlike vectors. Just copy these vectors, so we will proceed. Yeah, children, here one important point to be noted. So the angle between two parallel vectors is 0 degrees, whereas the angle between two anti-parallel vectors is how much? It is a 180 degrees. 180 degrees, this is a theta. It's very important. So the angle between two like vectors is 0 degrees, whereas the angle between two unlike vectors is 180 degrees. Kindly note, this is a very important point. Now the fifth one, let us see, children, is a co-initial vectors. It is what? Co-initial vectors. Co-initial vectors. For suppose children, let us say that. So here, from one common point, let us say that there is one common point. From here, let us say more than two persons. Let us say 3 persons. Okay, now from this common point, okay, now they are running in a different directions. Means here what? For example, here person A, let us take, and here is person B, and here is person C. That is person C. These 3 persons are starting from the same point and running with a different velocities in a different directions. Try to understand. So then how can we, if I want to represent the velocity of person A, person B, person C in a vector form, how it can be? Look at it. So here, this is a common point. From here, this is a velocity of a person A, and this is a velocity of person B, and this is velocity of person C. Now here I can say these three velocities, velocity is a vector quantity, these three are called co-initial vectors, which means what? The vectors whose initial point is same, means if the vectors are drawn from the common point, such a vectors are called co-initial vectors. Okay, fine children, that's great. Now let us see the sixth one, co-linear vectors. Co-linear vectors. Now let us see what are co-linear vectors. For suppose children, there is a running competition. Let us say that all persons are running along the same track, that is a straight line. The track also just straight line. It's not a curved path actually. It is a just straight line path. So all persons have to run along the same track and think that one person is running behind one more person. Just think like that actually. So there is a running competition where persons are running one after other with different velocities. Means what? So here is the same track. Means here let us say person A, one more person B, here person C. These all are running in the same direction along the same path. Now if I want to represent the velocity vector, velocities of these three persons, so those what we can say vector should be drawn along the same line. So which means what? The vectors which are lying along the same line are called collinear. Means for this I can say that, see, all vectors are in the, it's a velocity of a person A and a velocity of a person B and velocity of person C. Means here these are the vectors which are lying along the same line. Such a vectors are called collinear vectors. Okay, fine. Now let us see the seventh one. It is coplanar vectors. Coplanar vectors. Now children, so you might be knowing about a carom board. Okay, carom board. So if you can see carom board, look at it children. Let me take this example. So for suppose, so let us take this carom board children. So just think that coins are there. Okay, coins are placed in a proper order and those coins are hit with a striker. Children, when coins are hit with a striker, what will happen? Do you think that all coins will be going along the same line? No, just they'll be moving here and there. In all directions they will move, but in the plane of that board only. Yes or no? In that plane only they will move. Means for suppose, let us take this is a x-axis for sake of our convenience, and let us this consider as a y-axis. Means all coins will be moving in this xy plane only. All coins means every coin has its own velocity. Might be different velocities. May not be same. One coin may have a more velocity. One coin have a less velocity. Okay, what it may be? Different magnitudes, different directions. But don't you think that all coins will be moving in this xy plane only? Yes, it will be moving. Means for suppose, let us say here this one coin is there. Let us say coin A is moving in this direction. Okay, what it may be. So here coin B is moving in this direction. Let us say coin C is moving in this direction. Whatever may be the direction children, but they are in this plane only. So the vectors which belongs to the same plane are called coplanar vectors. Which means what children? They should lie in the same plane, either xy plane, yz plane or zx plane. Okay. So how can we represent? For suppose, let us take here is x-axis and here is y-axis. Now let us take their velocities only. For suppose here vector A, velocity of coin A, let us say is a VA in this direction. Okay, so now this is velocity of coin B in this direction. Now if you can look at here, this is velocity of coin C. So whatever may be the velocities children, so they all are lying, these all vectors are lying in the same plane. Such a vectors are called coplanar vectors. Okay children, so this is about co-initial vectors, collinear vectors, coplanar vectors. Just copy it. Now, so let us see here. Next vector, it is null vector or zero vector. Null or zero vector. So first let us see a definition, children, then we will try to understand. What is a null vector or what is a zero vector? The vector whose magnitude is 0 is called null vector or zero vector. Then you may find out, sir, as there is no magnitude only, then what is its purpose? Children, only for mathematical operations only we can use null vector or zero vectors. Now how to understand that what is the example for this null vector or zero vectors? So children will try to understand. For suppose, children, here is, let us say here is an earth surface, okay, and here is one object is there. Now this has to be thrown vertically upwards. For that, should we give some initial velocity? Yes, obviously we should give. Let us suppose it is thrown vertically upwards with a 5 meter per second. Now children, as this body is moving vertically upward direction, you tell me, just you think whether its velocity keeps on decreasing or increasing. Obviously keeps on decreasing because it is going against the gravity. Okay, fine. So here initially it might be 5 meter per second. So somewhere else after going, let us say it is going like this, going in this direction, let us say that. So at this point it might be 4 meter per second, here 3 meter per second, here 2 meter per second, here 1 meter per second. But after reaching maximum height, let us say that after reaching h max, maximum height, what happened? Its velocity is 0. Children, it's very important. So if any object is thrown vertically upwards, children, what happens after reaching maximum height or at maximum height? Velocity will be 0. Children, is velocity scalar or vector? Vector. Now what is its magnitude here? 0. So here velocity is a vector and its magnitude is 0. So this is the best example for null vector. So this is a vector with 0 magnitude. Children, it's very important. So here vector with 0 magnitude. Vector with 0 magnitude. The vector with 0 magnitude is called null vector, zero vector. The best example, children. So the velocity of an object at highest point is the best example for null vector or zero vector. Now one more thing, children. Here is a let us say the board is there. Now I am applying the force. Let us say 10 Newton, 20, 30 Newton. Now what is the displacement of this board now? The displacement of the board is 0 because it is not moved. So now displacement is a vector quantity and its value is how much? 0. So there in that case displacement is a what we can say null vector. Is it clear? So this is very important to understand. Now actually here two more points we need to understand. If any vector is added to the null vector, then what happens? We will get the same vector. Means for example vector A is added to this vector, that is it's a null vector is 0 only. So then what will happen? It will be A only. Means it won't get affected. Whether it is added or subtracted, there won't be any affected. But children, if any vector is multiplied through a 0 or what can say it's a dot product or cross product, the resultant will be again null vector only. That is 0 only we will get actually. Is it clear? So null vector we use only for a mathematical operations. So what is a null vector? The vector whose magnitude is 0 is called null vector. Is it clear? Fine. Now children, so let us take a ninth one. So before going to just write the name of that particular vector, let us take an example so that 100% we can understand what actually it is. Okay, fine. And look at here, children. So here is a horizontal surface. So here is an object, children. So let us say it is moving horizontally. Let us say towards x-axis with some velocity. So let us say this is moving in this direction. Okay, now with velocity I can say it's a 10 meter per second. So here is a velocity is a vector quantity. Okay, now fine. Now don't you think that, for example, let us say body mass, it has some mass. Let us say body mass is 2 kg. Okay, now children, don't you think that the body weight will act vertically downward direction? Yes, obviously it can act vertically downward direction. What is a weight, children? Weight is nothing but the force with which an object is pulled by the gravity. So which means what? Weight also weight also vector quantity only. So weight of the body will act in this direction. So weight, how to calculate? W is equal to mg. For suppose g is a 10, let us take. So 2 into 10 meter per second square. So this will be 20 Newton. So here weight is a vector quantity. Weight is a vector quantity. Now children, I can say that here velocity of the body and its weight are called orthogonal vectors. So I am going to call it as a orthogonal vectors. Let us see here, orthogonal vectors, orthogonal vectors. So then you should understand. By saying that you can understand, but how to define? You may get one doubt, sir, how can you say that the velocity and weight, these both are orthogonal vectors? Children, just try to understand, try to notice here. Children, what is the angle between these two vectors? Yes, now you will understand. The angle is 90 degrees. That's it. So children, the vectors which are mutually perpendicular to each other are called orthogonal vectors. So in a board exams, for 1 mark question it can be asked like this: what is the angle between orthogonal vectors? So what is it? It's 90 degrees. So if the angle between two vectors is 90 degrees, then only we can call those vectors as a orthogonal vectors. Is that clear, children? Fine. Yes. So orthogonal vectors, the vectors which are perpendicular to each other, which are perpendicular to each other. If the angle between two vectors is 90 degrees, those vectors are called orthogonal vectors. Okay, na? Fine. Now, so next let us see unit vectors. Unit vector. Children, here it's very simple. The name itself will give the concept. Means the vector with unit magnitude. The vector with unit magnitude is called unit vector. Children, actually there is so much of importance for a unit vector. So what we do is that today just we'll try to understand its definition, and regarding this unit vector and some important numericals, how unit vector can be calculated, we'll try to make one more video. Okay, children? Fine. So first, unit vector. So vector with a unit of magnitude. But how to calculate this? I mean, just I'll try to give just a rough idea. We are not going in depth actually. Okay, now fine. So children, in a previous class, okay, we discussed how can we represent vector. For example, vector A we can represent like this. Okay, and its magnitude we can represent with just a letter. So here A is the magnitude of its vector. Okay, children, fine. For suppose, so let us say here 20 Newton force in east direction is a vector only. Is a vector. Let us say here vector A representing the force. Its magnitude is here 20 Newton force is acting in east direction. But what is its magnitude? Just I can say 20 just. So that number, children, already we discussed. The magnitude of any vector is a scalar only. The magnitude of any vector is scalar only. Okay, na? Fine. Now what I want to do is that, children, try to understand. Now I want to look at here. Here is a vector and I am dividing with its own magnitude. See, magnitude even you also can write like this. In mod we can keep. Whether you can keep mod or simply if you are writing also, it is understood that it is a vector only. Or okay, sorry, it's a magnitude. Let's write it's a magnitude. Okay. What I am trying to do, I am dividing a vector with its own magnitude. Let us see here. So this is 20, what we can say, Newton force in east direction by its magnitude 20. 20 cancel. Now how much I got here? 1 Newton force east. 1 Newton force east. Now here what is its magnitude here? 1. Got it? Now here we got a 1, which means what here? If any vector is divided with its own magnitude, then we will get a unit vector. Children, unit vector we can represent like this. So unit vector cap we can keep. Okay, now small letter A I am using here, and this cap represent that it is a unit vector. Okay, children. So here unit vector, any unit vector, how can we get if any vector is divided with its own magnitude, then we will get its unit vector. It's a unit vector. Then what happens, children? For example, if any number is a divided, it is a multiplied with a particular unit vector, then what will happen? You will get that vector in that direction of unit vector. Means what is the purpose of unit vector, children? Here it's very, very important. If you want to convert any scalar into vector, you multiply with a unit vector. Yes or no? Yes, you can. For example, 40 is there. 40. Just 40 is what? It's a scalar. 40 is a scalar. Now it is multiplied with, for example, 1 meter per second. 1 meter per second velocity in each direction. Then what will happen? It will become 40 times of that. 40 meter per second in each direction, in that particular direction. Yes or no? So unit vector gives a direction. Is it clear, children? So it is about a unit vector. See, I am telling you. So in detail, we will discuss just introduction of the vectors only. Okay, na? Just copy this. Okay, children. So now, I think number I forgot. It might be 11th. Okay, whatever it may be. Just hope you are following the number, right? Yes, you can follow. So now, children, look at here. So now one more important. It is orthogonal. It is very, very important. It is a orthogonal unit vectors. Orthogonal unit vectors. So you may get one doubt, sir. Till now we discussed already about orthogonal vectors and unit vectors. Then whatever is orthogonal unit vectors, children, this is a very, 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 very important. Throughout vectors, we will be using orthogonal unit vectors only. Now, children, as already we learned about orthogonal vectors and unit vectors, now it will be very easy to us to understand what are orthogonal unit vectors. Children, it's very simple. Orthogonal means what actually? The angle between the two vectors must be 90 degrees. Unit vectors means what actually? The vectors with a unit magnitude are called orthogonal unit vectors. So children, what are orthogonal unit vectors? The vectors whose magnitude is unit and which are mutually perpendicular to each other are called orthogonal unit vectors. To understand this, children, let us take a Cartesian coordinate system. It's very easy to us to understand. Let us take here. So children, it is, we know there is an x-axis. Okay, here is y-axis and here is z-axis. Let us say the origin, children. It is the origin. It is what is the origin. For suppose children, so along x-axis direction, if I will take 1 centimeter length, for suppose, it's, let us say 0. If I will take a 1 centimeter length, 1 centimeter length. So 1 centimeter length in x direction I am taking, which means what? Don't you think it's a displacement? Yes, it is a displacement. 1 centimeter is a displacement. Am I clear? So like that only. So here also 1 centimeter I will take y-axis direction. And 1 centimeter length I will take a z-axis direction. Means 1 centimeter as I am saying, which means what here? 1 is what actually? Unit. So 1 centimeter, the displacement is 1 centimeter. Means in this case here, displacement is a unit vector. But now children here, in general, to represent a unit vector, again I am telling, in general, to represent a unit vector, we have a specific symbols. So for suppose children here, for suppose, so along the x-axis direction, the unit vector we use I cap. So I cap is a unit vector along x-axis. Whereas children, it's very, very important. So here j cap is a unit vector along y-axis. Whereas here, look at here, it's a k cap is a unit vector along z-axis. As I am saying unit vector, which means what children? Their magnitudes are equal to 1. Means I can write like this. The magnitude of I cap is equal to the magnitude of j cap is equal to the magnitude of k cap is equal to 1. Their magnitudes are equal to 1. Now children, what is the angle between I and j? Yes, it is 90 degrees. 90 degrees. Then what is the angle between j? Children, you may get out. Sir, it is j like this here. How it is 90? More than 90 you may think. Don't get confused. J vector, j is like this actual axis. So the angle between here j vector and k vector is 90. And the angle between the k vector and I vector is 90. So angle between any two means like this you can imagine. Children, it is a what we can say vector I, unit vector j, unit vector k. So if you can see, the angle between these three unit vectors is 90 degrees. So here I can say that here I cap, j cap and k cap, children. So these vectors are called orthogonal unit vectors. Why are we calling these vectors as orthogonal unit vectors? Because their magnitude is equal to 1 and the angle between any two vectors is 90 degrees. That's what these vectors called orthogonal unit vectors. Am I clear, children? Is it clear about orthogonal unit vectors? Okay, now just copy it. Now the very important, one more very important is that it is what actually position vector. Children, this is very important. So let us discuss position vector. Position vector. Children. So the name itself will give you position. For example, if one particle is there, if one object is there, so if you want to specify its position and a direction, we need a one vector that is called position vector, which specifies the position and direction of a particle either in a plane, along a straight line, or in a space is called position vector. So why I am saying along a straight line, a plane and space? Because we have position vector in a 1D, position vector in a 2D, position vector we have 3D also. So first we'll try to discuss position vector in a one dimension. Okay, na? So here position vector in a one dimension we'll discuss. Position vector in a one dimension. For suppose children here. So let us say it is x-axis. Okay, let me write here. So that, okay, let us say it is x-axis. So children, somewhere we have to start. Let us say this its origin is x-axis. Okay, now for suppose here one particle, try to understand, one particle in along about x-axis direction only. So it is traveled x units, let us say small x units, it traveled small x units, then its position vector with respect to the origin. So always position vector can be written with respect to the origin only. Here I can write its position vector is x I cap. Means it is understood that I cap means what? Along x-axis. Children, by seeing this x, you may get to know, sir, already x is there, which means x-axis, right? No, it's not that. For example, if I say that phi I cap, what does it mean? So let us say its position O2, it is let us say P. So here OP is its vector, or we also can represent with r cap is equal to phi I cap, which means what? You should understand that. So it has a 5 units in a x direction. 5 units in x direction. If somebody will write here, for example, it is a, it's a r cap is equal to, for example, some 7 j cap. So you should understand that it has 7 units along a what we can say y axis. What if it is r cap is written? For example, if r cap is written, for example, here let us write here. So if r cap is written, for example, I cap, it is understood that a vector has 5 units magnitude along x-axis. So for example, if r cap is written phi j cap, which means what? Vector has 5 units of magnitude along y-axis. For suppose r cap is written phi k cap, so which means what? It has 5 units of magnitude along z-axis. Then you make it wonder, sir, what if minus? Okay, let us take here. If here r cap is equal to minus phi I cap, which means what here? 5 units of magnitude along the negative x-axis. So here also same thing, here also let us take so minus phi j cap, so 5 units of length along negative y-axis. So here if you can take a minus phi k cap, means 5 units of length along the z-axis. So this is how actually we can represent a position vector in a 1D. Means with respect to the origin, the particle has traveled, for example, some x units along x-axis. Then what we can say position vector can be represented r cap is equal to x I cap. Is it clear? So this is a position vector in a 1D. Okay, na? So position vector in a 1D. So how can we represent, children? Let me write here. So it can be written, it can be. So r cap is equal to x I cap, or r cap is equal to y j cap, r cap is equal to z k cap. So this is how we can represent in a one dimension. Now let us see how the position vector is in along the 2 dimension. Means we need to take a plane, either we can take a xy plane, yz plane, z plane, it's not a matter. So for sake of our convenience, let us take here is, it is x axis and here is a y axis. Okay, children, we know that I cap is a unit vector along x axis, whereas here j cap is a unit vector along y axis, and here is a origin, and is a origin O. So let us say particle is here, the particle is here. Okay, na? So let us say the particle P. So let us join its initial position to final position. Let us draw a vector. Okay, so here this OP will give you the position vector in a plane 2D. So we also can represent with the r cap now. Also can represent with the r cap. Now if you can see, dear children, here, if you can see here, so if you just try to just draw a projection here, fine. Means here means along x-axis direction, so it has covered some x units, whereas let us draw one more projection on a y-axis. Okay, so here along y-axis, children, it has covered y units. Let us say that it's a y units. Then position vector can be written as here OP bar or r bar is equal to x I cap plus y j cap. So this is how we can represent a position vector. If it is a yz plane, so you will get a yz terms. If it is a zk plane, you will get a zk. So let me write here. Let us write here. So here r cap is equal to y j cap plus z k cap similarly, and r cap is equal to z k cap plus x I cap. So these are the position vector in xy plane, yz plane, zx plane. Is it clear? Fine. It's a position, but how to calculate its magnitude, children, it's very, very important. So if you can see, magnitude means for this we have to calculate. This we know x. As it is a y, children, obviously this also y. Am I clear? Now let us apply the Pythagoras theory. You can apply the Pythagoras theory. So it's a y j cap. Let's say it's a y j cap. If you can apply the Pythagoras theory, children, so it can be mod r is equal to, okay, try it, it's very, very important. It's a magnitude of the r is equal to, so means Pythagoras theory, it's a hypotenuse square is equal to, for example, let me write here, let us say OA, it is OP, let us say that. So here OP square is equal to OA square plus here AP square. It is AP square here. So what is its so OP square? OP square is equal means what, children? It's a R square is equal to OA square x I cap whole square plus this will be y j cap whole square it is. So it can be written as R square is equal to x square I square. I square value is 1. Why? I is a unit magnitude. It's a unit vector whose magnitude is 1. 1 square is 1 only. It means what here? So here I square is equal to j square is equal to even k square also 1 only. So I can add x square plus y square. So here r is equal to square root of x square plus y square. So children, this is how we also can calculate the magnitude in that xy plane. So magnitude of the position vector in xy plane. Then in a yz plane, children, how can we calculate here? R is equal to, it is y square plus z square. In a z, what we can say, it's a z and x plane, xz plane. So position vector magnitude can be written as a x square plus z square. So this is the position vector. What is the position vector? How it can be written in a 1 dimension and how it can be written in a 2 dimension, that is in a plane, and how we can calculate its magnitude. Okay, just copy this. Once we will see in a 3D how it can be written. Fine, children. So now we will see position vector in a 3D. Position vector in a 3D. So for this, for example, one particle is there in a space. In a space means what, children? We need to see along x-axis, y-axis, z-axis. Okay, now fine. So look at here. So let us say it is a x-axis, and here is y-axis, and here is, let us say, z-axis, and it's origin, children. It is origin. Is it clear? Fine. So along x-axis, we know that I cap is a unit vector. Along y-axis, j cap is a unit vector. Along z-axis, k cap is a unit vector. For suppose one particle is here, children, actually the particle is right one, is very, very, very important, means somewhere else here. So this z vector is like this, children, z vector is like this, and one particle is here. So which means what? It has some distance from x-axis some y-axis, even from z-axis also. But here on board it is not possible to show here means. In air I can't show you. It's not possible. So for that only, let me try to draw. Let us say this is a position where it's a particle P, let us say. Okay. Now. So this is x units. So children here, so here x units along x-axis, y units along y-axis, I mean y length it is. So z length along a z-axis actually. So now it is its initial, let us draw a position vector. Let us draw it's a position vector. So this we can say it's a OP bar, or we also can say R bar. So how can we write children here? It can be written as OP bar is equal to R bar is equal to x I cap plus y j cap plus z k cap. So how its magnitude can be calculated? So in a previously, in the case of what we can say plane, how it is calculated, same pattern we can follow, but derivation is not required here. So here R is equal to, the magnitude of the position vector in 3D is written as x square plus y square plus z square. Okay children, fine. So this is about types of vectors. Children, in a previous class we discussed about what actually, we discussed what is a vector and how it can be represented. Whereas in today's class we cover the basic types of vectors. Okay children, fine. Thank you so much. All the very best.